Hello everybody, welcome back. Today we're going to be talking about different angle relationships with the transversal. It's important to note in this image we have two parallel lines, M and N, and they're cut by transversal T. And that gives us the different groups of angles here. They're labeled here 1, 2, 3, 4, 5, 6, 7, 8. And the first type of angle we're going to talk about is corresponding angles. Corresponding angles. Alright, and I'm going to point out several pairs of corresponding angles. First pair I'm going to point out is angles 1 and angle 5. 1 and 5. Please note 1 and 5. How they're facing the same way, they're on the same side of the transversal. Another pair of corresponding angles, 2 and 6. 2 and 6, they correspond. 3 and 7 correspond. And then finally 4 and 8 correspond. It's important to note that when you have corresponding angles, the pairs of angles always have the same measure. In fact, all the different types of angle pairs we talk about in this lesson, they will have the same measure. So please note corresponding angles. Alright, we're going to talk about another type of angle pairs here when we're dealing with the transversal. Next one, alternate interior. Alternate interior angles. Let's point out alternate interior angles. Angles 3 and 6. And then also angles 4 and 5. Alternate interior. Interior because they're on the inside of the two parallel lines, and alternating as in they alternate on either side of the transversal. And once again, alternate interior angles, just like corresponding, angle measures are the same. Angle measures are the same. Angles 3 and 6 have the same measure. Angles 4 and 5 have the same measure. Alternate interior angles. And lastly, alternate exterior angles. Alternate exterior angles. Let's focus on those for a moment. 1 and 8. Notice they're on the outside of the parallel lines, and they are on alternating sides of the transversal, hence the name alternate exterior angles. 2 and 7. 2 and 7 are the other pair of alternate exterior angles, and just like the others, they do have the same measure. Angles 2 and 7 have the same measure. Angles 1 and 8 have the same measure. Alright, let's try a few exercises just to really see this in action. Relationship between 1 and 4. Let's focus on 1 and 4. Well, they are on alternating sides of the transversal, and they are inside the parallel lines. So we're going to call 1 and 4 alternate interior angles. Alternate interior angles. Here we have another transversal A, and they are stating that X and Y are parallel lines. Which angles form corresponding angles? Alright, we're going to focus on the corresponding angles here. Alright, corresponding angles 1 and 5 are corresponding. 4 and 8 correspond to each other. 2 and 6. 3 and 7. Note that since they're corresponding, they would all have the same measure. So 4 sets of corresponding angles. Let's look at this one. AB lines parallel. It's transversal C. And we have angle 1, they're telling us, is 34 degrees. What's the measure of angle 5? Well, we have to note first that they are corresponding. And since they're corresponding, they're going to have the same measure. The measure of angle 5 will also be 34 degrees. All right, let's look at this one here. Lines J and K are parallel, transversal T. And now our focus is on angle 1. They're going to tell us that angle 1 has a measure of 63 degrees. What's the measure of angle 4? Now that's an interesting relationship. 1 and 4. 1 and 4 are a linear pair. They're a linear pair since they're formed from the same, off of the same line here, the transversal. And linear pairs of angles always add up to 180 degrees. So what we need to do is simply take 180 and subtract 63. And looks like we're going to get 117 degrees. Angle 4 is 117 degrees. Last one. Here's an interesting scenario where we have two sets of parallel lines. So the other set of parallel lines are acting as two different transversals to the situation. A and E are parallel, M and N are parallel. So all the rules apply. We are going to say that angle 1 here is 108 degrees. Angle 1 is 108 degrees. What's the measure of angle 3 down here? Well, given that A is acting, the line A is acting as a transversal, 1 and 3 have the relationship of alternate exterior angles. And since they're alternate exterior, they will have the same exact measure to each other, 108 degrees for angle 3. Thank you very much. Thanks for watching.